Hi, it's Mr. Johnson. I'm actually going to try for a second time to work my way through some information for you. The first time it lasted a little bit too long, so I apologize if I go quickly, but let me know if you have questions and I'll help clarify them. The goal of this video is to help you understand how we can analyze pedigrees. I'll remind you that a pedigree is a family tree that tracks one trait through several generations. Shaded is affected by the trait. Unshaded is not affected by the trait. Circles are females, squares are males. The numbers on the left show generations, starting with 1 is the first generation, 2, 3, and 3. And then at the bottom of each person, what we like to do is we like to have numbers. So generation 1, here's person 1 and 2. Generation 2, person 1, 2, 3, 4. And generation 3, person 1, 2, 3. We restart numbering at each generation. Okay, so here is my basic tutorial on how to analyze pedigrees. Remember, you can always rewatch this, and you can always go and rewatch those Edpuzzles or find them on Google or on YouTube, rather. Okay, so this very first one, to start us out, I've given you a lot of information. I've told you what is dominant, what's recessive, so that we can solve it together. It says, the family tree below shows the trait of having attached earlobes. Okay, so it's showing attached earlobes. It says then having free earlobes is dominant. So I can write a capital F equals free. And we know that the other possibility, people with attached earlobes, are shaded in. So we know the other possibility is attached. Okay, and the other thing I can add is that they are the ones that are shaded in. So we know that they're the ones that have their shape filled. Okay, so let's start with the first question. Describe the sex and characteristics of person A. Another way of saying person A, remember, is 1-1. Okay, so what's 1-1? Well, we see that they're unshaded. We see that they don't have any shading going on. Whoops, sorry, I'm trying to erase that. I didn't mean to give you a seasickness there. So we see that 1-1 is shaded, which means that they have the trait. And remember, above I said people with attached earlobes are shaded in, and we see here that attached is recessive, and so we can give it any letter we want. Since we're talking about earlobes, let's use an E. So we know that, oh no, I already have F, sorry. So capital F, lowercase f, that first one, 1-1 is shaded in, so we know that it's little f, little f. The reason we know that is because the information at the top, the reading, told us what's dominant, what's recessive, and we know that shaded is the recessive characteristic. Now, the nice thing that we can do is we can actually go ahead. Normally, you don't get to just be told what's dominant, recessive, but since we know this is a recessive trait, then all of the other ones that are shaded in are also 2 little f's. So we can go through and we can label all of those that are shaded in as little f, little f. Let me change the color here so we can see it a little easier. Okay. So, what is the sex and characteristics of person labeled A? Well, A is a box. So what gender is that? Well, box is, what the heck? All right. Let's try that again. A box is a male. Male. E at the end. Okay. So, what is the characteristic of that person? Well, the characteristic, since they're shaded in, is attached. Moving on, describe the genotype. They want the letters of the person labeled B. So if I look down here, person B. Well, another way of saying person B is person 2-2. So what are they? Well, they're shaded in. And so we know that they have to be little f because shaded in is recessive. That's the only way you can get that trait. Describe the genotype of the person labeled C. Another way of writing C is 2-3. So 2-3, person C. There's two ways we can tell this. First of all, we know that they don't have, again, there are two ways to figure this out. One is that we know that they don't have the trait, which is recessive. So since they don't have it, they have to have one capital F. And if we look at their kids down here, how can their kids get two little f's? Well, it's if their dad, person 2-3, had a little f to give. That's the only way that person 3-1 and 3-2, right, these two, could have the trait. But there's another way. The other way, and I'll write this in red to have it be a different color, is that if we look at 1-1, we know that 1-1 has only little f's to give. And they're one of the parents. We see that the person that we're talking about or asking about has the dominant trait, which means that they have to have that big F. But they got a little f from dad, which is person 1-1. So let's just go ahead and fill out the rest of this. Okay, so if we look at person 1-1, it's big, little f. Person 1-2 has the unshaded trait. So we know that they have to be at least one big F. Now, if all of their kids were also unshaded, then we would probably guess it would be big F, big F. It might not be, but we could guess. However, let's look at this person right here. Person 2-2. Person 2-2 has the trait, which means that they have two little f's. So how could we get two little f's? Well, mom and dad had to give one. Dad obviously gave one here because that's all he has to give. But mom had to have a little f to give in order for their kid to have two little f's, one from each parent. So that's how we can tell that. Let's keep filling this out. What's 2-1? 2-1, well, got a big F, 2-1 got a little f from person 1-1, dad, right? So we know they got a little f from dad. What did they get from mom? Well, what characteristic are they? They don't have the trait, so they're unshaded. So it's a big F. Person 2-3, letter C. Well, we already figured out what C is. Big F, little f, because they got one from dad, 1-1, and one from mom, 1-2. And last but not least, could the person labeled D have a recessive allele? So that person, that's the only one we haven't labeled yet. Look, we've labeled all of the other ones. Could they have a recessive allele? Well, do they have the trait or not? No, they don't. So that means that they have a big F for sure. I'll write that both places. And who did they get it from? Well, they got it right here. They got it up here from dad. What did they get from mom? Well, mom only has a little f to give. So the only possible option is a little f from that mom. And that's a basic idea about how to analyze pedigrees. Now let's go into dominant and recessive. Recessive pedigrees. And this is where I'm going to speed up because I'm kind of losing time. I apologize. So I'm going to boil it down to some essentials. Recessives. So if a trait is recessive, it's probably rare. It probably doesn't show up very much. Now, it can, but we'll get into that a little bit later. It can skip generations. So if you've ever heard of a trait, skipping, your grandparents had it, your mom and dad, or, your mom didn't have it, neither did any of her siblings, but then suddenly you have it. Well, that could be because it's a recessive gene. It affects males and females equally. So I'm just kind of checking these off. By the way, I forgot to mention this at the beginning. It's not a bad idea. It's not a bad idea to take notes on this. It'll help you in the long run. If you need to pause right now to take notes, you certainly can. You haven't lost any time. You can always go back and rewatch this. So I apologize. I forgot to mention that at the beginning. Here is the key. So key that I'm going to write it in red. If someone has the trait, but there are two parents without the trait, right here, then we know it's recessive. In fact, this right here is, dang it. Let me try that again. This right here is really important. I'm going to write it in red. Two parents without the trait have a person with the trait. So let's look at this. We'll label it quick. 1, 2, 1, 2, 3. Okay. So these two parents, 1, 1 and 1, 2. Do they have the trait? No. But they have a child right here who has it. Now, how is that possible? I'll tell you what's not possible. We can't have little e times little e give us big E anything. It's not possible. Because one of those two parents would have had to give or had to have a big E to give it. So that right there tells us if we have two parents without the trait, we can't have two recessive parents have a child that's dominant. That's not possible. So that tells me right there, this is what I look for in every pedigree. I instantly look for it. Do I have two parents like this without the trait that have a child with the trait? If I do, it's going to be a recessive trait that I'm tracking. So how is this possible then? It has to be big E, little e, times big E, little e. I've forgotten what letters I'm using. I've used so many letters, but I think I'm using E's. If I'm not, that's fine. In that case, then it could have gotten a little e from dad, 1, 1, and a little e from mom, 1, 2. So that's huge. That's how we can have traits that skip generations. Look, we have the same pattern here, right? So we have two parents without the trait. They have a child with the trait. So that would mean they have to be big R, little r, times big R, little r, and that would give us a kid with two little r's. And we can see the same pattern down here. Two parents here don't have it. One kid has it. Boom. We know it's recessive. Let's move on to dominant traits. So how do we know a trait is dominant? Well, we don't totally know, but here are some key. And we don't really know on any of these if they're dominant or recessive, but here are some basic ideas. First of all, shows up a lot in that pedigree. I'll point out for just a minute that dominant traits aren't always most common and recessive traits aren't always most unseen. We'll talk more about that later. I'm talking about that particular pedigree. Every affected person, and this is key, has at least one affected parent. So we come down here. If we look at 2-3, 2-5, who is their affected parent? Well, 1, 1, 2. What about any of these? Who are their affected parents? Well, right here and right here. Now they're not related, right? I mean, they're not brother and sister here, right? I'll kind of draw that line right there. But if we go back up to the top, two unaffected parents cannot have an affected child. So it's kind of the opposite of what we talked about. Right here, look, if we have two parents that are not affected, can they have any children that are affected? No. So again, if you look, there's a lot of people in this pedigree that have it. It can't skip any generations, and we don't have anybody that's missing the trait have a child with the trait. And I think I'm going to stop for there. If you have questions, let me know. I'll try and post some more videos later.